In this video, we're going to try to prove that profession, a categorical variable, is acting as a moderator. Okay, and here's the 5 different levels of this categorical variable, nominal variable. 1 is executives, 2 is blue-collar workers, 3 is sales, 4 is statistics teachers, and 5 is other. So what we're going to try to show is that the relationship between salary, a person's annual salary, and the quality of life is the same or not the same for each one of these groups. Example, let's say that the relationship between salary and quality of life is significant for the salespeople, but not for anybody else, none of these other levels, then this would be, in fact, a moderator variable. But first, I'm going to cheat a little bit. That's not really cheating. I'm just going to go ahead and try these other ways to see if there's moderation going on. So there's several ways. The first way, let's try the graphing way. We're going to do legacy. Get in there, you. We're going to do scatter plots. We're going to do simple, define. So the Y is the dependent quality of life. X is the predictor variable. That is your X. And I'm going to split them up between the professions, right? Set markers by. And I'm going to get a scatter plot with 1,000,000 dots on it. I'm going to double click. I'm going to go to this little tiny thing. Hey, get out of there, you. I'm going to go to this little tiny thing up here. It's got the multiple tentacles. I'm going to click on it. And I could tell right off the bat that, see that purple line? It's much different than the other lines. So that the one for other, it's yellow. It's probably won't show up in the video here. But most of these other lines are pretty much similar, like the green, blue, and the gold here, whatever they are. They're all relatively the same. And this yellow one, which you could barely see, it's a little bit off, but it too is pretty much, we all within roughly the same thing. They all go roughly the same direction. Some go a little bit up, some go a little bit down. Nothing to write home about. But this purple one, oh yeah, it goes sky high. So there's hint number 1 that this is a moderator. In other words, one of the levels of profession has a much more strong correlation between quality of life and salary. So that's way 1. Let's try way 2. Again, this is kind of cheating. I'm going to go to data. I'm going to split the file way down here at the bottom. Beep. Compare to groups. I'm going to split them up by profession. Right. And then I'm simply going to run a correlation, because there's only 2 variables, right, between the quality of life and the annual salary. So if I click this, according to that graph, only one of those lines should be significant, and let's see which one it is. So here's executives. Nope, wasn't them. Blue-collar workers. Nope, not significant. Salespeople. Nope, not significant. Statistics teachers. Oh, yeah. Yeah, it is significant only for statistics teachers. These other people down here, let me see if I can get this on the screen for you. The other is not significant as well. So again, if you split the file, it runs these things one at a time, all by themselves. It's like dummy coding the fast way. But this shows that there is a significant relationship between quality of life and money, salary, but only for the statistics teachers, because we like money. All right. So we know ahead of time this thing is a moderator, categorical moderator, but let us continue with the video. We're going to do this 2 different ways. The first way is the traditional way, which is rather long and complicated, I'm afraid to say. And the second way is with the Hayes process, which is about 1,000,000 times faster. All right, first things first. Since we're looking at a categorical or a nominal variable with these, we need to make a dummy code for each one of these guys and go from there. That's how I do it, so let's start with that. I'm going to show you how to dummy code just one of these, and then we'll zip forward here. So I'm going to take the executives, which are labeled with a number 1 here, and I'm going to make a new dummy coded variable by going to transform, recode into a different variable. I'm going to put profession in there. And so the first dummy code, I'm going to call it exec dummy. I always mark my dummy codes with the word dummy. Gotta spell it right. Dummy. Big dummy. Oh, we got two of them wrong in there. Sorry. And then you gotta, and we copy and paste into the new label. Hit change. We're gonna go ahead and switch the values around. All right, so if it was a 1 in the old data set that identified them as executives, they get a 1 here. You add everybody else, all other values, get a 0. Add. I'm going to do a second one for you real quick, just to hammer it on home here. So we're going to go to transform, recode into a different variable, kick you out, kick profession back in. And so the second one was a blue collar, so I'm just going to call it blue dummy. Blue dummy. Copy, pasty, changey. So here's a quick way to do this. We just take the 1. So if it was a 2 in the old data set, it still gets a 1, and everybody else gets a 0. You just click change and you do them all like that. So I'm going to go ahead and do them all like that. So give me 1 second. And that was it. So let's double check these. So let's just pick sales. I'm going to double click on that. So only people with the sales would be marked with a 1 here, and that's right there in the middle. So it worked, okay? So let's get back to this. Second thing we got to do is we got to center the salary variable. In other words, whatever your predictor is, you have to center it, and there's another video earlier in this series that shows you how to center a variable. But the main thing is you got to find the mean and annual salary. I just want the mean. Okay, I'll get standard deviation. Beep. All right, there's the mean of the data, $69,519, 69519. Okay, so we're going to create a new variable, transform. We're going to compute a new variable, and we're going to call it salary centered. So we kick over salary minus, and what was it? 69519. 69519. 69519. Boom. So that's going to give us a new variable. And what you're looking at here is the distance from the mean. That's what this is, right? Half should be positive numbers, half should be lower numbers. So there's our centered variable. All right. Now, here comes the hard part. Not really, but we have to create 5 new variables that's the product of this centered variable times each one of these dummy variables. So in other words, we're going to make a new variable called executive dummy times salary centered. Another one is blue collar dummy times salary centered, etc., for all 5 of these. Let me show you how to do one real quick. I always name mine product. So it's the product of salary centered, and let's do executives first. Exec. Okay. So what we do is we take that salary centered guy and we're going to multiply it by executive dummy. Boop. So that gives us the data strictly for the executives. See, if we did this, the product one, you're only going to see numbers here for the executives. As you go down, if they're not executives, they won't have any information in this dummy coded product variable. So I'm going to repeat that for all of the variables. Please hold. All right, I always double check to make sure I do these things right. So we go to data view and we scroll over to our dummy coded variables. Actually, the product variables. So the products, good. So stats teachers was what, number 4? So right, you see how the data split up? So only those that were dummy coded with the positive 1 on each one of these dummy coded variables gets a number. So that's going to come in very handy when we start doing our regression check. So this is the way we're going to do it first. We're going to do analyze, regression, linear. The DV is quality of life. Now, we always start with the centered salary variable, and it should come out exactly the same as the salary date variable. Okay, it doesn't matter if you use the centered or the original variable. You should get the same correlation because it works off the variance, don't you know? Okay, so and then we hit next. So I'm gonna go ahead and assume that the executive group is the reference group. So I'm going to leave the executoids out, right? So everything we get as a result is going to be in comparison to, in reference to, the executives. Okay, so we're going to stick in the blue-collar worker guys and girls, the sales people, next, stats teachers, woohoo, next, and the other guys next. So this is hierarchical. Whenever you hit that next button, that makes it a hierarchical, okay? So let's see what kind of statistics we want here. Let me move this so you can see it. And I'm just doing this by habit. You don't need a lot of this stuff for this video, okay? And I think we're ready to go. Let's click OK. And we got the output. First thing I look at is that the centered variable mean, it should be really close to 0, and it is, right? So it's negative 0.2, which is pretty dang close to 0. Really don't care about the correlational box at this time. This box tells us that we did hierarchical because we entered them one at a time. And this is your main box right here. So the first model is strictly with the centered salary variable versus the quality of life, right? And it says by itself, it was not significant. So the second group we added down here were the blue-collar workers. So the blue-collar workers was not significant compared to the executives, right? The third group is the sales guys. So when we added the sales guys in there, again, there was no significant change there. But lucky number 4, the fourth row here, that's where we added stats teachers, woot woot. Stat teachers, yes, that was significant for stats teachers. So in other words, the relationship between salary and quality of life seems to be significant only for stats teachers and not for anybody else compared to the executives, okay? So, and I would assume that if we ran with the executives in here, they would not be as significant as well because the overall group was not significant. But, that's something else. We'll check that later, I guess. And our ANOVAs kind of agree with this. So you look at the fourth model here, it is significant. Now remember, if you have a significant model and you start adding other variables to it, the next model should also be significant because you already found one that was significant. So according to this, we do have one level of the profession ID is significantly correlated between quality and how much money they make, Stats teachers, yeah, we like money. Money, money, money. Money makes us happy. So that's the first part. I'm gonna do the process coming up. The Hayes process, such a great guy. He gave it to free, so you gotta like the guy. So we go to regression, and then you go to the process, and your Y variable is your quality of life. Your X variable is money, 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 filthy, filthy money. So a moderator is number 1. Remember, a mediator is number 4, model 4. But a moderator is number 1. And so our moderator variable, we think it's profession. Boom. And I don't think we need any of the options in here. Not for this video, you guys. Okay, so let's just click out of that. And we'll click OK. And go get a cup of coffee or something because it takes a minute. And again, it literally took a minute there. So, but here it is. Okay, so your Y variable, your DV is quality of life, your X variable is annual salary, and your suspected moderator is profession. So let's just see what this says here. So we have our R squared, not very big, but big enough, and it is significant. So that means something's going on in there somewhere. And here's the first model. So salary, profession, and interaction. So this one says there is some kind of interaction between your moderator and it is significant, right? 0.007. Let's keep going down here and see what it says. And so what this one found was, okay, model 4 was the stats teachers. It is very significant, right? And there's no 0 between the lower limit confidence interval and the upper limit confidence interval. But it also says there's something in number 3. So number 3 were the sales guys. We got a little bit different on the other way we did it. But all we're looking for is if it is a significant interaction, and it is. We got that right here, interaction number 1, and it is significant, very significant, 0.007. So I hope this helps. This was a long one. This is a hard one. MGZ out.